This is AB Calculus prep session we had at Townview High School on November 21st. This is problem 2, and this is the section that has to do with PVA. This is PVA, position, velocity, acceleration. Essentially, you have to look in this whole hierarchy of position, velocity, and acceleration where you are now, and then what you're being asked to do with that. In this case, we have a particle moves along the y-axis with velocity given by v of t equals t sine t squared, for t is greater than or equals 0. And in which function, up or down, is, in which direction up or down is the particle moving at time t equals 1.5 y. And so really velocity will be, we have to ask ourselves the question, is at t equals 1.5 seconds, is v of t greater than 0? And if greater than 0, the particle is moving up. If t is less than 0, the particle is moving downward. And so what we have to do is take this function and substitute in 1.5 for t. So here's going to be part A I'm putting over to the side up here. V of 1.5 is equal to 1.5 times sine of 1.5 squared. It's t squared, right? Well, v of 1.5 is equal to 1.5 times the sine, and what is 1.5 squared? Well, it's going to be 2.25. And that's just something I know. I know 15 squared is 225, so 1.5 squared is going to be 2.25. And so really, to find out, to answer this question, if v of t is greater than 0, if we know if the sine of 2.25 is positive, we know the speed is increasing. If sine is actually the particle is moving up. If the sine of 2.25 is negative, we know the particle is moving downward. Well, on a unit circle, you might recall this. We have a unit circle here. We should know that pi radians, and pi is approximately equal to 3.14, is over here at 180 degrees. And sine is the y value on a coordinate plane, and of course cosine is the x value. So anywhere in quadrants 1 or 2, the sine is positive. Well, for 2.25 radians, which is between definitely between 0 and pi, in fact it's going to be 2.25 radians is going to be something like this angle over here I'm describing in red. So we know that the sine of 2.25 is positive. And so our answer is, since sine of 2.25 is greater than 0, the particle is moving upward. Or let me put further logic in there. V of t is greater than 0, so particle is moving upward. So that's problem part A with the justification. Now, the justification is that since, right, that since sign 2.25 is greater than 0. Part B, find the acceleration of the particle at time t equals 1.5. Is the velocity of the particle increasing at t equals 1.5? Why or why not? So what I'll do is take advantage of the knowledge for part B. We have A of t is equal to v prime of t, and that's going to be the first derivative of our velocity. So we're going to have the original thing, which is t, times the derivative of this second thing, so this is product rule. So t times the derivative of sine t squared, well, that's going to be cosine of t squared times the derivative of the inside, which is 2t. And so v prime of t is equal to, and I forgot here, second part, we got this velocity, this sine t squared times the derivative of t, which is 1. So v prime of t equals 2t squared cosine t squared plus sine of t squared. Well, to find this out, we're not dealing with the angles here. And remember, we would have, if we work this all out, v prime of 1.5, which is what we're looking for the acceleration, is 2 times 1.5 squared cosine 2.25. Remember, 1.5 squared is 2.25 plus sine of 2.25. And so really, to do this without a calculator, I can't do this without a calculator, but with a calculator, I'm going to go to the calculator page here, and after having differentiated and worked this out, I get around to 3 decimal places, negative 2.049. Negative 2.049. And actually, the way AP readers grade it, you could have put negative 2.048 in the first 3 that worked out. So either way, I like to use the proper rounding. So that's going to be our answer to that first part. Then the question is the velocity of the particle increasing at t equals 1.5. Well, what's happening is the velocity of the particle is decreasing because acceleration is the first derivative of velocity. So we will say the velocity of the particle is decreasing at t equals 1.5 because A of t, which equals v prime of t, is less than 0. So that'll be our answer. Now, one more thing. This works out the problem, but you could also take this original function here and if you use in your TI-84 calculator, put math 8, and this would be derivative at a point, and put in the function, which I did. In the case of the problem, it's t sine t squared. Well, I put x sine x squared, and then put in 1.5 for x. Well, that gave us the negative 2.049. So based on using the calculator, this was a calculator problem. I wouldn't have had to actually work all this out and take the derivative like I did. So anyway, good luck to you, and thanks for viewing.